You will be demonstrating how light can be emitted through the decomposition of lucigenin and how this light can be used to set off other reactions. Take it away, Matt.
Okay, I'm Matt Bierowski, as you said, a student here. I'm going to be discussing two types of luminescence. The first one, I'm just going to give a brief discussion, is fluorescence, as we see here. Fluorescence is the emission of light by a substance through absorption of energy from a separate source. I have a black light set up here, which is emitting UV light, and that is being absorbed and making these three fluorescent dyes fluoresce. This is lucigenin, fluorescein, and rhodamine. Now, that's fluorescence. The main part of my experiment is chemiluminescence. That is the emission of light by a substance through a chemical reaction. Now, the chemical that we're going to use is lucigenin, and it is a nitrate salt, dissolves completely in water. It's a strong electrolyte. I'm going to mix that together with hydrogen peroxide, and we're going to see what happens.
Good job, Bierowski. I started that clap.
All right. So, what exactly just happened here? Well, the hydrogen peroxide combines with the lucigenin in the solution, and two oxygens from the hydrogen peroxide get sandwiched in between, as you can see in the second compound up there. Yes. In between there, two oxygens get sandwiched in between those two sets of aromatic rings, and the oxygen electrons like to repel each other, and so the oxygens don't like to be there, so it becomes a very unstable compound, and that compound naturally will then start to decompose. And it's during this decomposition process that energy is released. That energy then goes into our product, which excites electrons from bonding orbitals to higher energy non-bonding orbitals. In this instance, it's a singlet. And as those electrons return to ground state through a relaxation period, it emits a blue photon. Now that's the chemiluminescence part through the chemistry. But if you guys remember, you don't have to go back. If you guys remember, when we looked at this, it was bluish green. Why is it not just all blue? That's actually because in this reaction we have chemiluminescence and fluorescence going on simultaneously. As I just discussed about that blue photon, when that's emitted during the relaxation as it returns to ground state, some energy from that is actually absorbed by the original lucigenin before reacting with the hydrogen peroxide, and that excites electrons to anti-bonding orbitals again. And as they return to ground state, they release a green color. That's the fluorescence part. It's absorbing energy in the form of a photon from a separate source, which is our product here. Now, so if we can use a chemical reaction to excite other parts of a solution, let's see what happens when we mix lucigenin with two other fluorescent dyes, fluorescein and rhodamine.
Oh, hell yeah. Good job, Bierowski.
He's so talented.
Oh, no. He's dominating the competition.
No surprise, exactly what happened here with the lucigenin. That blue photon that was emitted from the chemical reaction is absorbed by the fluorescent dyes, and electrons in those cases also become excited. And then as they return to ground state, they emit a yellowish and a reddish color. Now, in conclusion, one thing I do want to state here is the energy from the blue photon can only be used to excite fluorescent dyes that have colors with higher wavelengths. Because a higher wavelength, as we know, equals less energy. That you can get that from the formula of E equals Planck's constant times speed of light over lambda, which is wavelength. These are inversely proportional, so as wavelength goes up, energy is going to go down. And yellow and red happen to have higher wavelengths, which is why they're able to absorb energy from that blue photon for themselves to become excited, and then emit these colors as the electrons are returning to ground state. And that is the fluorescence over here, and that is chemiluminescence with fluorescence in this one, and all of them actually as well.
job, Bierowski.